dear children, today we are going to learn about the lesson number 5, acids, bases and salts. The objective of the lesson are Arrhenius theory of acids and bases, concentration of acid or a base, pH of a solution, pH of acid and base, and the concept of salts. We have earlier seen that some foodstuffs are sour to taste while some others are bitter. Some substances are slippery or soapy to touch. When these substances are studied scientifically, it is found that they contain acidic and basic substances respectively. We have also learned an easy and safe method of using an indicator like litmus to identify acids and bases. How are acids and alkalis identified with the help of litmus paper? We shall now learn more about acids and bases. But let us first review what the molecules of compounds are made up of. Some compounds are seen to have H plus ion as the basic radical in their molecules. These are all acids. Some compounds are seen to have OH plus ion as the acidic radical in their molecules. These all are bases. Ionic compounds which have basic radical other than H plus and OH minus radical are called salts. Now let's begin the concept of recapitulation. The molecules of an ionic compound has two constituents, namely cations, positive ion or basic radicals, and anion, negative ion or acidic radicals. There is a force of attraction between positive radicals and negative radicals. That is called ionic bond. The force of attraction between one positive charge on a cation and one negative charge on an anion makes one ionic bond. While studying static electricity, we have learned that there is a natural tendency of any body to change from an electric charged state into an electrically neutral state. Let us see how the sodium and chlorine atoms form the sodium radical and the chlorine radical. As a result, how the sodium chloride is formed. Let's see the diagram. The outermost shell of the sodium and the chlorine atom is not a complete octet. However, outermost shell in both sodium and chlorine is a complete octet. Electronic configuration with a complete octet indicates a stable state. Ionic bond is formed between the oppositely charged sodium and chlorine ion, and therefore ionic compound sodium chloride having very high stability is formed. Now let's begin the dissociation of ionic compounds. On mixing the substances as shown here, what are the resulting mixtures formed by mixing the following substances called? Number 1, if we mix the water and salt, what will be the resulting mixture? Number 2, if we mix the water and sugar, what will be the resulting mixture? Third, if we mix the water and sand, what will be the resulting mixture? Fourth, if we mix the water and sawdust, what will be the resulting mixture? So my dear friends, in the first two cases, sugar and salt, because sugar and salt completely dissolve with water. That's why in this case we will get the homogeneous mixture. And in the third and fourth cases where we dissolve the sand and the sawdust in water, we know that the sand and sawdust cannot dissolve with water. That's why such a mixture is said to be the heterogeneous mixture. On dissolving in water, ionic compound forms an aqueous solution. In the solid state, the oppositely charged ions in the ionic compound are sitting side by side. When an ionic compound begins to dissolve in water, the water molecules push themselves in between the ions of the compound and separate them from each other. That's why the ionic compound dissociate while forming an aqueous solution as shown in the figure. Each of the dissociated ion in the aqueous solution is surrounded by water molecules. This state is indicated by writing AQ, aqueous solution, means aqueous, on the right of the symbol of the ion. Now let's begin to study the Arrhenius theory of acids and bases. Theory of acids and bases was discovered in the year of 1887. This theory gives definition of acids and bases. Acid is a substance which on dissolving in water give rise to H plus ion as the cation. For example, HCl, H2SO4, etc. Let's see the equation. If we dissolve the HCl solution in water, we will get H plus ion and Cl minus ion. In this, the HCl substance dissociate with water and give H plus ion. That's why the HCl is said to be the acid. Second example we are free to take H2SO4. If we start to dissociate with water, then we will get H plus and HSO4 minus. Here also, after dissociation, we are getting H plus ion. It indicates that the given compound is acid. Use your brain power and try to find out the answers. What are the names of NH3, Na2O, CaO? When these compounds are mixed with water, they combine with water. Complete the following table by writing the ions formed by their combination with water. A base is a substance which on dissolving in water give rise to OH minus ion as anion. For example, NaOH, KOH, etc. When the sodium hydroxide dissociate with water, it will give Na plus and OH minus ion. Here, OH minus ion indicates the given substance is base. Now let's begin the classification of acids and bases. Acids and bases are classified into strong and weak acids on the basis of the dissociation in their aqueous solution. The strong acid is defined as a substance and dissolving in water dissociate almost completely, and the resulting aqueous solution contains mainly H plus ion as cation and the concerned acidic radical. For example, HCl, HBr, HNO3, H2SO4, these all are the example of strong acid. Weak acid is a substance and dissolving with water give rise to H plus ion. The resulting mixture contains the H plus ion. It means that the compound on dissolving with water, it will give rise to H plus ion. It shows the acidic nature of a compound. The examples of weak acids are acetic acid, formic acid, H2CO3, etc. A strong base is a substance on dissolving with water. A strong base dissociates almost completely, and the resulting aqueous solution contains mainly OH minus ion and the basic radicals. For example, NaOH, KOH and many more. Weak base. On dissolving in water, a weak base does not dissolve completely. The resulting aqueous solution contains OH minus ion as an ion. The example of weak base is NH4OH. The last one is alkali. The bases which are highly soluble in water are called alkali. For example, NaOH, KOH, etc. NaOH and KOH are strong alkalis, while NH3 is a weak alkali. Basicity and acidity. Complete the following table. Acids and bases are classified according to their basicity and acidity respectively. In this table, they given the different acids and bases. We have to identify number of H plus ions obtained from one molecule of acid and number of OH minus ion obtained from one molecule of base. Basicity of acid is defined as the number of H plus ions obtained by the dissociation of one molecule of acid is called its basicity. Acidity of bases is defined as the number of OH minus ions obtained by the dissociation of one molecule of base is called its acidity. Use your brain power and on the basis of the above table give examples of monobasic